Okay, and so now that I've done that, I have to show the video again, or show it to the video again. That was definitely not recording it, so there's the answers to those ones. Here's the answers to these ones. I will slowly scroll, and you can pause the video as you need to. There we go. So, the last little piece here, today's lesson is relatively short as well. And there's a good amount of practice for it. Is this. Find me this page. If you haven't already, chemical reaction descriptions. And this is going to lead us into our next lab, which we will do tomorrow in the classroom because the lab is booked. Okay, here we go. So, chemical reaction descriptions. This is kind of the peak of where this all goes. We've looked at skeleton equations. I've touched how to balance those. Word equation to skeleton equations. And now, what happens if I give them to you as a sentence or a paragraph description of a chemical reaction? Or I show you a video. Let's say I put something up on YouTube here in class. You should be able to give me, from the video, a balanced chemical reaction for what you just witnessed. It's not out of the realm of skills that I should be able to expect from you. And so here's what that would look like. Sometimes you'll be given a sentence or a paragraph description of a chemical reaction, like you will tomorrow in the lab that we're going to do. And you will be asked to create a balanced equation. It's going to be similar to the stuff that we've already done, but it's now just kind of putting all of those pieces together. Your first task will always be to turn the description or, again, the YouTube video that I could give you into a word equation. Hey, Olivia, what's up? Yes, she is. You want to take that description, you want to turn it into a word equation. So the stuff that I gave you yesterday, you now need to be able to create. I'll show you how we do that. And then the following steps are the same thing we would have done on Friday. Once you've got your word equation, you turn each compound, whether it's ionic, covalent, or a common name for a compound, or you take that element name and you turn it into the correct chemical formula. As before, this is the same careful step you have to make here. I've got the asterisks in there. We can add more of them. This is where you're looking for diatomics. This is where you're looking for polyatomics. This is where you're looking for covalents. You're going to set up your skeleton equation. And then you'd have to go ahead and balance the thing. So I've got one example for you, and then I'm going to let you play. I've got 10, 18 practice questions that are going to lead you into the lab that we're going to do tomorrow. So here we go. A piece of metallic zinc is placed in a blue solution of copper 2 sulfate. A reddish-brown layer of a brown layer of metallic copper forms in a clear solution of zinc sulfate. So there's your description of what happens. I could be describing to you a YouTube video. I could be describing to you a demo. We wrote it down. I just said it. And now the task you guys are going to have is create for me the balanced chemical equation for what we just witnessed. It would look like this. If the first thing you want to do is you want to identify the reactants, you want to identify the products. What are the reactants here? What is coming together to do something? The zinc and the copper 2 sulfate. So those two things, a piece of metallic zinc is placed in a blue solution of copper 2 sulfate. Those are the two things that are coming together initially. Those are going to form your reactants. So when you've got zinc, zinc is a metal. When you have a pure metal, what's the formula going to be for zinc? It's just going to be Zn. Any of the metals listed there, if I tell you you have just zinc, it's just whatever the periodic table tells you that thing is going to be. So that metallic zinc is going to show up as, not the formula, we're going to do the word equation first, zinc. Who cares that it's metallic? It's zinc. That's the only thing you have to throw down there. Plus the copper 2 sulfate. You'll have your copper, Roman numeral 2 sulfate. For the word equation, you're just pulling it out of the sentences that are listed. Now, it needs to be understood that when these things react, when you're building the word equation, what needs to go between the reactants and the products? Thought so. What needs to go between the reactants and the products? An arrow. In math, it would be an equal sign. In chemistry, it's an arrow to tell you that one combination of things leads to another. And then what shows up? You get a reddish-brown layer of metallic copper. The only thing there that we would include in the word equation is what? Do I need the fact that it's reddish and brown? No, it's just copper forms in a clear solution of, so something separate is the zinc sulfate. So the first thing you need to be able to do is just distill all of the unimportant pieces out and just say, okay, well, here's actually what's happening. I've got zinc plus copper 2 sulfate is going to give me copper plus zinc sulfate, and now we can go ahead and we can create the skeleton equation for this. Zinc and copper are both just metals. Zinc is going to be Zn, copper is going to be Cu. And at this stage, because they're just on their own, they're showing up as atoms, not ions, and so you don't need the charges here. So we've got Zn, and on this side of the arrow, we've got Cu. I should be leaving gaps out front here because we are going to go ahead and balance this thing. So I didn't do that here, so let's go back and fix that. Let's take that arrow and push it back a little ways. I want that guy there. So there's my arrow. How are we going to go ahead and make copper 2 sulfate now? This is an ionic compound. Copper is Cu. What's the charge on copper if I'm building copper 2 sulfate? How do you know? Because they give it to us in the name. Yeah. That Roman numeral there tells you which charge to use. We don't even have to look at the periodic table. And now we've got sulfate. For those of you who haven't worked with it enough to memorize what sulfate is, we'd go back and we'd say, okay, cool. Where's my periodic table? Sulfate ends in ATE, and so it's going to be one of those polyatomic ions found on the back. It's this guy right here. The formula is SO4, charge of -2. So that's going to be SO4, charge of -2. And now I need to take these two and build the compound. What's the formula for the compound going to be? Made of these two things. It is just going to be CuSO4. How'd you do that, Sam? Yeah, the charges are equal and opposite. They just cancel each other out. And so I only need one of each to do this. If you swapped and dropped, then you'd put the 2 in the 2, but then the last step in swap and drop is always to reduce. So your formula for this guy, copper 2 sulfate, is just going to be CuSO4. And we create the space out front for us to go ahead and balance this thing. And then the last thing we're going to create over here is the zinc sulfate. Now all of a sudden we care about the charge on the zinc. Because it's part of an ionic compound, we need to know what the charge is. So let's go find zinc. Zinc is Zn. Can't see from here what that one is. So I look at my periodic table, it's +2. Sulfate we've already done. SO4 -2. These charges are equal and opposite. One's +2, one's -2. So to balance them out, I just need one of each. So this is going to be Zn, SO4, and I leave my blank. The last step here is to now go ahead and say, okay, well, we're actually going to balance this. So, to review, because some of us were in Mexico when this was first gone through. Some of us are struggling with the balancing. Some of us were deathly ill when I went through balancing the first time. For a whole host of reasons, people weren't here, so let's go through it. Review real quick. To balance these things, you draw a vertical line down from the arrow that separates the reactants and the products. And then on each side, you make the same list of all of the individual elements present on each side. So I've got Zn, Cu, S, and O. Each one of those gets their own labeling, and now I just go ahead and I count everything. As it sits right now, how much zinc do I have over here? I got 1. There's no coefficient, there's no subscript. Just like in math, if there's no numbers listed, we assume that it's a 1. Then we're going to jump over here. The Cu, there's only 1 Cu. There's only 1 sulfur. There's 4 oxygens, because when you've got a subscript, it only applies to what's immediately next to it. And on the right-hand side, we'll count them in the same order. I've got 1 zinc, 1 copper, 1 sulfur, 4 oxygens. So the beauty of this reaction is it's already balanced. If you build it properly, it's balanced. So then we could toss a 1, bless you, 1, 1, 1. So this wasn't a great example of balancing because I didn't have to balance it. But there it is. That's the process you would go through. Questions, comments, concerns? Okay. Would you like to see another example of this process? Okay, I'll do one more. Okay, what's a good one to do for here? Let's look at something that is, someone suggested 7. 7 looks kind of wordy. I'm not going to do 7 because I actually want you to do 7. I'll do I'll do 6 because there's a few that show up like 6. And 6 is nice because it gives me some space on the page to actually do some of the balancing here, where you guys won't have space to do on the rest of these. So here we go. So the description says, when heated, solid aluminum oxide breaks down to produce aluminum metal and oxygen gas. It's a good example to do. What are the reactants here? Careful. Lemise, you said aluminum and oxide? Oh, not and, just aluminum oxide? Yes, I love that. That's better. That is the correct fix. If aluminum and oxygen were separated, it wouldn't be aluminum and oxide, it would be aluminum and oxygen. Aluminum and oxygen, if the names are listed as they are on the periodic table, that would be separate elements. But because this ends in IDE, what this is telling you is that for this particular reaction, you only have one reactant. The only reactant is aluminum oxide. So the word equation is going to be aluminum oxide, and then it's just going to be an arrow. That is the only product, or sorry, the only reactant. You're taking aluminum oxide and you're heating it. Heat is not a reactant. Aluminum oxide is the only thing there. And it's going to do what? It's going to break down. This breakdown is where you're going to get that arrow to produce what? Well, it's going to produce aluminum metal. I'm not going to name it as aluminum metal. I'm just going to call it aluminum plus oxygen. So that's the word equation. I've pulled out all the things that don't matter. It doesn't matter that aluminum's a metal. It doesn't matter that oxygen's a gas. It's true, but as far as our word equation goes, aluminum oxide, arrow, aluminum plus oxygen. That's all you need. And now let's go ahead and build these things. Aluminum is just Al. It's the easiest one to do. Well, we're going to leave a space out in front of it. We'll put the arrow right there. Whenever you have a metal, it just shows up as the symbol. Plus, space. Now oxygen, what's special about oxygen? It's one of the diatomics. If you recall, there are 7 of them. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Nobody asked me about the thing that shows up below iodine last week. And interestingly enough, across my feed, just randomly this weekend, I saw a really cool little video on astatine. Astatine is actually the rarest naturally occurring element on Earth, and it doesn't exist long enough for us to know what it does. It could be diatomic, we don't know. If it shows up, it disappears so fast that we have no idea how it behaves. We don't even know what it looks like. They think it behaves like iodine, but they don't know. It's weird. It's wildly radioactive. We'll talk about radioactivity when we hit the physics unit. Astatine, so it's just those top ones. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Those 7 are the diatomics. So oxygen on its own will forever show up as O2. On its own, oxygen will show up as O2. So now let's go back to the one that's actually going to make us do a little bit of work, aluminum oxide. This is a compound. Both elements are present. So I'm going to need aluminum, Al, and I need the charge on aluminum, +3. Oxygen is O with a charge of -2. And so to build aluminum oxide, I need to create the compound formula based on the balancing of these charges. If Al is +3 and oxygen is -2, what's the compound going to be? It's going to be Al2O3. I can swap and drop, and then there is nothing to reduce. Al2O3. I've got my space out front, and now I'm going to go ahead and balance this thing. I drop my line down from the arrow. I've got Al and O. I've got Al and O on both sides. The list should be in the same order just to make your comparing easier. Aluminum, how many aluminums do I have on the left-hand side right now? 2. How many oxygens do I have? 3. On the right-hand side, how many aluminums do I have? 1. On the right-hand side, how many oxygens do I have? 2. So, I gave you guys a set of balancing tips. At this stage, if you've done everything I've assigned to you, you should have done just a ton of balancing questions. And so you should actually recognize at this stage that the tips that I have given you are not the best thing to follow. Because the tips I've given you said, what should you balance first? No. The tips I've given you say anything but oxygen. In fact, I told you left to right. So aluminum would be the first thing you'd balance here. But as soon as I do that, what's going to happen? We're going to have to go and deal with an odd number of oxygens on the left and an even number of oxygens on the right. So before we even, this is one of those ones where the tips that I've given you are never 100%. They're just pretty good tips. This is one of those ones where if you've done enough balancing, you should recognize that following my tips is actually going to lead you to a whole bunch more work than is necessary. Because if you look at the oxygens, they only show up in one space on either side. Here they show up in groups of 3. Here they show up in groups of 2. So what should your first act be when balancing this question? There is a tip to follow. What's the, yeah? Double what's giving you the odd problem. So this is the odd problem. The O3 is the problem. So the first thing we're going to do, if we can see that coming, the first thing we're going to do is we're going to double this. I'm going to put a 2 in front of the Al2O3. And now we're going to recount what's on the left. How many aluminums do I now have on the left-hand side? 4. How many oxygens do I now have on the left-hand side? I have 2 groups of Al2O3. So I have 2 times 3 is 6 oxygens. So now to balance my aluminums, it's easy. What am I going to put in front here? I need 4, and they're coming in groups of 1 over here. So I'm just going to toss a 4 right there. My aluminums are balanced. What do I have to do to the oxygens? Put a 3 out front there, because 3 times 2 is 6. And now this thing is balanced. When aluminum oxide is heated, it breaks down to produce aluminum metal and oxygen gas, and these are the ratios. 2 molecules, for lack of a better word, of the compound Al2O3 will produce 4 individual aluminum atoms and 3 molecules of oxygen gas. Yes, Luca? The charge on aluminum was +3. The charge on oxygen is -2. So when I build Al2O3, wait, you said on the left side? Yeah, what I'm going to get. When you build Al2O3, you swap and drop these charges. So the 2 is going to go on the aluminum, the 3 is going to go on the oxygen. Or the other way I had you think about it is, if aluminum is bringing +3, if every atom of aluminum or ion of aluminum is bringing a +3 charge, and every ion of oxygen is bringing a -2 charge, what's the smallest number that 3 and 2 both go into? That would, of course, be 6. So I would need 2 +3s and 3 -2s to balance those charges. Comments, questions, concerns? Okay. You have, and so what I've just done here is I want you to do now as you go through the practice. From the description, create the word equation. From the word equation, create the skeleton equation, and then balance that thing. You have 17 of them now to do. 9 off this page and 8 off this page. I would like you to do all of them over the next 45 minutes in preparation for tomorrow's lab. After we do the lab, there will be a quiz. Maybe. Maybe not. See what happens. Okay, there you go. If you'd like the mini whiteboards, they're over here on the side to help you with your balancing, or you can use scrap paper, or you can use all the big whiteboards. The tools are available for you to use at your disposal. On your market, say giver.